All right, so we are going to start with Chapter 9 notes with a video. So, you recently have taken your Chapter 7, Chapter 8 test. This will be your homework assignment to follow along with notes. Hopefully, it's not too painful. And hopefully, you guys enjoy the cartoon where you have these two sciences that tell you that all the tests point to the same conclusion that this indeed is a big banana. So hypothesis testing is going to kind of uh, be the start of our next part of the course where we're going to not only estimate parameters using confidence intervals, but we're going to kind of test claims. So the best way to kind of explain this is by looking at an example. So a government agency has received numerous complaints that a particular restaurant has been selling underweight hamburgers. The restaurant advertises that its patties are a quarter pound, which indicates 4 ounces. So if you have a complaint that the hamburgers are really underweight, how can you really tell if they are underweight? So how would people know, or this restaurant would figure out if it's actually underweight? And if you've sat in stats long enough, generally when we want to kind of investigate something, we want to take a sample. And we want to kind of figure out maybe the mean weight of all these hamburgers that have actually been used to see if maybe it's credible, this claim or this complaint that's being made. But how do you know if this one X bar or this one sample mean of the weights of these hamburgers is something that you expect to happen versus one that's unlikely to happen? So, what would the weight need to be in order for you maybe to say, probably this claim or this complaint is true? Or maybe that this within the parameters there. So it should be something where it's about a quarter of a pound. So what kind of sample mean would indicate that it's not that, or that it's less than that? Because if you're underweight hamburgers, it should be less than that. Well, that's what we're going to do with this entire unit here. So when we're talking about a hypothesis test, that's going to help you decide, like, is this X bar really something that you expect to happen versus something that's unlikely to happen? All right, so what's a hypothesis test? Well, a hypothesis test is used to assess the evidence provided by data about some claim concerning the population. So within our hamburger, I guess, example there, you're talking about underweight hamburgers. So what we're doing is we're assessing the evidence, which is going to be taking that sample mean and matching it up to the claim about the population, which is going to be all hamburger patties. So again, like I just told you, we're going to test a claim. We're going to take that sample and we're going to compute one of our statistics. And our two major statistics for AP Stats are going to be taking sample means or sample proportions. So the whole point of this unit, like I've been kind of alluding to, is to determine whether our sample statistic, this X bar, this P hat, if it's just likely to occur by chance. Is it natural variation? Is it something that we would expect to see? Or is it something statistically significant within our results that may indicate some important conclusion about our data? So we got two things here. Is it something that we expect to see by just natural chance or natural variation? Or is it something that maybe says that something's going wrong or something's gone awry? All right, so is it one of our sample means that are likely to occur? So you could take a look at this kind of normal distribution, kind of looks more like a T distribution due to the higher area underneath the tails there. But if it's one of those sample means that's likely to occur, it's going to fall within the major peak there that you can see indicated by the shading that I'm going to shade here. So it's going to fall within the normal curve here, okay? So that's going to be if it's likely to occur, all right? But our job is not just to determine if it's likely to occur. We want to actually see, is it something that's going to be unlikely or within this small area here? So you guys can kind of see me drawing in the tail areas here. This is when we would start saying that, we're not likely to see this. So maybe something is really going wrong. Maybe these hamburgers are really underweight. So maybe this complaint actually has some valid truth to it. So if we do find an X bar within that small tail area that I'm now erasing, all right, maybe that means that we have some significant evidence there. So when we start talking about the nature of a hypothesis test, we always suppose first that the effect is not present. So within that hamburger example, we're going to suppose that the hamburger patties are not underweight. We're going to assume that they are fine the way they are. And then we're going to see if we have enough evidence to prove against that what's called the supposition. So we're supposing that the hamburgers are not underweight, but then we're going to collect data to say if there's evidence against that, which is the claim there is that they are underweight, okay? So for an example there is that we have sampled 100 hamburger patties and calculated the sample mean that is 10 ounces lower than what the company claims. Now again, this has nothing to really do with that first 4-ounce claim, but this is just to kind of get the idea. So we have like a not present effect, okay? So the hamburgers are not underweight, and then we're going to take like a sample mean, and then we're going to calculate that and then do some comparison there. All right, this is really good. Like murder trials are really good for the next kind of like example of this. So a murder trial, you're innocent until proven guilty. So the effect is that you're not guilty, and then lawyers build up evidence to say, are you guilty enough? Is there enough evidence present? And if there's not enough evidence present, then you're going to not go to jail, all right? Because they have to prove beyond a shadow of a doubt that you committed this murder. And if you didn't, then you are going to be released, because in the United States, you are innocent until proven guilty, which means that you have to have enough proof against the claim that, or against the supposition that you're not guilty to prove that you are guilty. All right, so kind of use that as kind of something that you can kind of wrap your brains around about hypothesis testing there. Oh, and this is the nice slide there that I just went through. So if you want to pause and read through the slide and rewind me, do that. Let's talk about stating hypotheses. For every hypothesis test, there are 2 sets of hypotheses that you must state. The first being what's called the null hypothesis. Now, this is the no difference hypothesis. So where this is the statement being tested, this is the statement about no effect or no difference. So basically, this is kind of like that. You're supposing that it's not present. Okay, so in the hamburger example, we have supposed that they were not underweight. So the null hypothesis there would be that the hamburgers are not underweight. And then we compare that to what's called the alternative, which is the statement that we suspect is true. And in the hamburger patty example, we're talking about them actually being underweight. All right, generally with the null hypothesis there, we have HO. So it's pronounced H sub 0 or HO. You'll hear me call it HO a lot. The alternative is going to be HA. So H naught represents the null hypothesis, or that no difference. The alternative is HA. So that would be your ho and your ha. Okay, so we're going to talk now about writing hypothesis statements. So the hypothesis statements always contain parameters. They never have statistics in there. So they always will contain a mu for means, a p for proportions. They could even contain sigmas, all right? And we should know that that's our population standard deviation. Later in the course, towards May, we're going to be talking about beta. If you've been to AP review, I kind of alluded towards what beta represented. It's called a population slope of a regression line. We'll be doing some linear stuff later in the course. Don't worry about that too much now. All right, so the forms here for the null hypothesis is that the parameter mu, p, sigma, beta are always going to be equal to some hypothesized value there. They're always going to be equal to. The alternative is where it changes. So the alternative there, okay, is when you have your HA, and that parameter could be greater than said hypothesized value. So the parameter could be larger than that. So that means it could be right in the tail over here to the right. So that means it may be above said hypothesized value, okay? Well, it's not always going to be above that hypothesized value. Sometimes the parameter may be less than that hypothesized value. So that means it would be over here to the left, all right, in that left tail. And sometimes we may not know direction. We may not know if it's greater than the hypothesized value. We may not know it's less than the hypothesized value. So we just may say, instead of it being just equal to the hypothesized value for the null, it may just not be equal to. And this is probably one of the new things here, is that we may get some issues in both tail areas. So if it's just different from said hypothesized value, it could be either lower than or higher than that. So it could be in either tail, and where we don't really care if it's in one tail versus the other. We just want to make a claim that it's different from. So maybe for this third one right here, let me star that up real quick. You may want to put that that's the different from. That's different from instead of greater than or less than. It's just not equal to. So not equal to is different from there. Okay, let's go through a couple examples with this. So first, a government agency has received numerous complaints that a particular restaurant has been selling underweight hamburgers. This is from that first example. The restaurant advertises that its patties are 1/4 pound. All right, so we need to kind of come up with a set of hypotheses. So we need to come up with a H sub 0, and we need to come up with a HA, which is the alternative. So going back to the idea here that the restaurant is advertising that its patties are 1/4 pound, means that we know that the weights there should be 4 ounces. So here we should say that the mean, my pen's not working really well apparently. So we should say that the mean should be equal to 4 ounces, should be equal to that 4 ounces. But here, since it's underweight, that's going to allude to that alternative. All right, so with that null hypothesis, we usually represent that with an H sub 0 and a colon, where mu is going to be equal to 4, and then we're going to have our alternative there. Now, if it's underweight, we're trying to say that maybe that true mean there, it should be less than 4 ounces. So with our HO, which is going to be our null, mu should be equal to 4, but HA, mu should be less than 4. And probably on this next transition, it kind of looks a little bit better, so you guys can read it. We do need to make sure that we define what this parameter is, where mu is equal to the true mean weight of those hamburger patties. So that's the true mean weight of those hamburger patties there. All right, next one is a car dealer advertises that, a car dealer advertises that is new. I don't know if that even makes sense. A car dealer advertises that is new. I guess it means it's new. Subcompact models get 47 miles per gallon. So that it's, I think that should be it's new. Subcompact model gets 47 miles per gallon. So you suspect that the mileage may be overrated. So if it's going to talk about that mileage, that miles per gallon, so that's going to be like that average, okay? So that's going to be the average there. So again, we're going to have like the average. So if it's overrated, you may think something like, okay, so that might be higher than what we expected, which means that we're going to get numbers that are reported to be lower than that 47. So overrated, don't just think if it says overrated, it's going to be greater than. That's not going to be true. So in this case, it's going to be our mu is going to be equal to 47 and mu is less than 47. So our HO is going to be the null hypothesis that it equals 47 miles per gallon, and HA is going to be that the mean is less than that. Because remember, if it's overrated, that means it's reporting higher, or it may be reporting higher numbers. So you're actually getting lower miles per gallon. Okay, I know that's going to be a little bit odd for some of you guys, but think about your car. If it's advertised to get 47 miles per gallon and it's like you think that's going to be overrated, that's because you're getting less miles per gallon. Maybe you only be getting like 35. Well, that's not anywhere close to 47, so it's overrated. Okay. The last one here for this example set is going to be number 3. Many older homes have electrical systems that use fuses rather than circuit breakers. So a manufacturer of 40A fuses wants to make sure that the mean amperage at which its fuses burn out is in fact 40. Now, if that mean amperage is lower than 40, the customers will complain because the fuses require replacement too often. If the amperage is higher than 40, the manufacturer may be liable for damage due to an electrical system due to fuse malfunction. So we got a couple of issues here. The mean amperage can't be too low where customers will complain. It can't be too high or the manufacturer might be liable. All right, so we kind of need it just right. So here in this case, if it's lower than, we would have issues. If it's higher than, we would have issues. So this time we want to do a two-sided. All right, so when we have this not equal to symbol here, this refers to a two-sided. So in this case, we had issues if it may be lower than 40. We may have issues if it's higher than 40. So here we just need it to be 40, and we need to know if it's not 40. Because if it's not 40, we're going to have issues either way. Either we're going to have customers complaining, or we're going to have manufacturers that may be liable for damage. Either way, not good. So we're going to test the claim that it should be 40 because it needs to be 40. And then if it's either less than or greater than 40, we're going to have issues. So we just want to test the alternative there, that it's different from 40. So where the mean is going to be that mu is going to be the true mean amperage for those fuses. All right. We're going to go ahead and stop here for the first video. All right. Make sure that you rewind if you need to, grab notes. If you have questions, we can address those tomorrow, but hopefully you have up until this point filled out. Thanks.